We now know enough to define our own token contract. Before we do that, however, we need to think about what kinds of token state transactions we want to allow. The contract we'll develop will only allow for the issuance of new token states onto the ledger. We'll leave it as an exercise for students at the end of the bootcamp to extend it to allow for the transfer of token states between parties. So what does a token state issuance transaction look like? Well, we know it'll have no inputs because the issuer is creating a new token from nothing. We know it'll have one output, the new token state, and the only condition we'll impose on this token state will be that its value must be positive. And it'll have a command of type issue, and this command will require a signature from the issuer. So let's take a look at how these requirements translate into actual contract code. It can be helpful to divide the constraints imposed by a contract into three categories. Firstly, we can think of constraints on the shape of the transaction. So the number of inputs, the number of commands, the number of outputs, etc. Then we can think about constraints on the contents of the transaction. So we can think about whether the states and the commands have the right types, do the fields of the states have the right values, are fields changing when they shouldn't be changing, or are there fields that shouldn't change but are changing. And finally, we can think about constraints on the signers of the transaction. So are the right people listed as the required signers on the transaction? And are there any unnecessary required signatures listed? So in the case of our token contract, what constraints are we going to impose? Well, in terms of the shape, remember it's an issuance transaction, so we want no inputs, and then we're going to have one output and one command. In terms of the contents of the transaction, we know that we want the output to be a token state. We know that we want the amount of the output token state to be positive, and we know that we want the command to be an issue command. And then finally, in terms of signers, we require that the issuer is a signer. Let's implement token contract now. Let's open up the skeleton token contract definition that we've provided. And our goal is to modify this definition just as we did with the token state so that the token contract meets the design we just laid out. And to guide us in the writing of token contract, we've written a series of tests. So let's open those up now. So this is just like the state test, right? We're going to put a series of tests here and we're going to uncomment them and make them pass one by one. And once all the tests pass, we'll know we've properly implemented our contract. And we can see these tests are using a slightly different syntax. So they're using this ledger contract DSL syntax. So you can see here at the top, we're creating some fake identities, Alice and Bob, and we're creating a token state. And then here in each test, we're using what's called the contract DSL to create transactions and assert that they either fail or verify. So in this case here, token contract requires 0 inputs in the transaction. Remember that one of our requirements was that the transaction had 0 inputs because it's an issuance. It has outputs, but it doesn't have an input. And here we're basically creating a transaction and we're giving it an input. And because we've given it an input, we're asserting that it fails. We're asserting that this transaction will fail contract verification. Meanwhile, we create a second transaction, and this time we don't give it an input, and we check that it's valid, that it passes contract verification. And so your goal is to go through, uncomment all these tests, and get the and modify the definition of token contract so that these tests pass. Just before we do this, we just need to do one thing, which is to update IntelliJ's compiler settings so that the classes are compiled with their parameter names. This is something that's required by Corda's serialization framework. And if you don't perform this step, you'll get errors that say something like constructor parameter doesn't refer to a property. So we need to update the IDE's compiler settings. And the way we do this is just by copying over this compiler XML file from here in lib to here in the idea folder. There we go. So here we're saying that we want to compile our Java classes with the parameters, with the parameter names. Then we need to do a build and a complete rebuild of the project, and that will force the IDE to pick up the changed compiler settings. And so now we're ready to go, and so we can actually go and run those contract tests. As with the state test, there's several resources at your disposal. So there is a contract definition here under Java examples. So I am a contract. You can take a look at this here, and it does all kinds of verification inside the verify method here. So you can take a look at some of these examples as ways to work out how to do various things. And as before, we also have the API docs online. So if I go to docs.corda.net and open Corda apps and then Corda API, I can open the contracts API page and look at the API related to contracts. And so before moving on to the next section, your job is to modify the token contract so that it passes all the contract tests. Good luck.